Good day, ma'am, and to those students who are watching this video. I am here together with my groupmates to report our topic, which is all about Hierarchical Task Analysis, or HTA. Introduction: Analysis and approaching to task analysis. So mainly, this is a theory and just introduction. For the learning outcomes, going to describe the HTA and its features and then explain the purpose of test analysis and modeling. Then describe broadcast analysis and UCSD process. At least analysis. What is the relation for the process of user-centered system design? So, for the next is explain and show how the results of an HTA can be used to improve the usability of proposed interactive system. Task analysis. The result of task analysis is a description of the task that user undertake when interacting with the system. It also involves how individual carry out tasks. Describe an existing system or task before the serious design work starts on a new system to replace it. It provides a means of analyzing and describing the jobs and tasks that people do so that they can be supported by interactive computer system. Approaches to task analysis. There are several approaches to task analysis, but we are going to focus on one type of task analysis, the hierarchical task analysis. But some tasks are not in the form of hierarchy, so do not force all tasks into the same shape or pattern. Generally, task analysis involves a focus on the goals and action, procedures or method that users carry out, what users know about their work and tasks, the psychological process such as perception and memory, object and entities on which users act, objects and attributes, and how they are related. The following output of task analysis: 1. A hierarchical task analysis. 2. Task analysis based upon other structures. 3. The problem statement. This is the first element required. 4. Observation of existing systems. 5. Analyze and profile the user's population. Description: A hierarchical task analysis, or HTA, describes an activity in terms of its specific goals, sub-goals, operation, and plans. Once the analysis is complete, the task activity is described in detail. Uses: to construct an in-depth list of goals or tasks associated with a specific process.
Description: A hierarchical task analysis, or HTA, describes an activity in terms of its specific goals, sub-goals, operation, and plans. Once the analysis is complete, the task activity is described in detail. Uses: to construct an in-depth list of goals or tasks associated with a specific process. How do I use this tool? Number 1, define tasks being analyzed, as well as the purpose of the task analysis. Number 2, conduct data collection. It pay particular attention to the areas such as the technology, machine, and team member interaction decision to better understanding the process. Number 3, determine the overall goal of the task. This should be in a place at the top of the task hierarchy. Number 4, determine task sub-goal. It decomposes the overall goal into corresponding sub-goals should comprise the tasks necessary to accomplish the overall goal. Number 5, perform sub-goal decomposition. Sub-goals should be further broken down into additional sub-goals and operation. Continue this process until you reach an appropriate operation, which specifies the action that actually needs to be done to accomplish the goal. There should always be an operation at the bottom level of any branch within an HTA, And the last number is number 6. Development plans analysis. After description, all sub-goals and operation, and then add the plans. Plans explain how a goal should be accomplished. This may be in the format do A, then do B, then do C, or do A, or do B, and do C. And the next is hierarchical task analysis, or HTA. HTA is an extension of the fundamental task analysis human factors practitioners know so well. Both analyses describe the tasks and subtasks at the detailed level and allow designers to illustrate different potential task sequences that may occur through an integration with the system. Hierarchical structure, hierarchical task analysis in several ways. Each TAs have a strict hierarchical structure with the primary goals represented at the top and tasks or subtasks represented below. See example number 1. Each TAs provide information regarding user higher and lower level goals, plans, conditions that are necessary for specific action to take place, conditions that are necessary are to take place to take place and operation things that people do within a task. HTAs can be used as a basis for subsequent analysis, such as the SERPA error analysis and or a critical path analysis. Steps within an HTA are numbered based on where they fall within the hierarchical task analysis, do have pros and cons, and may be better suited to certain use case than other methods. Below, we outline the pros and cons of this method. The pros, each TA provides extensive information about the task like goals, plans, and operation. Can be highly detailed, can be used for subsequent analysis such as error analysis, and can be easily portrayed or interpreted though tabular or in diagrammatic formats. And the cons can be time and resources intensive, and not all tasks require the level of the granularity that HTA provides. Generally take away. Use an HTA analysis when one is interested in obtaining a complete detailed picture of a task, including goals, sub-goals, operation, plans, and additional aspects like areas of the task sequence that have potential for error. And this is the example 1 of an HTA of a check bank account task with a mobile banking application. As we see here, there's a note that the items of the HTA highlighted in red are subtasks that the researcher believes are extraneous and may be eliminated in the following iterations of the system.
Hierarchical Task Analysis, or HTA, is most suitable for analyzing tasks that have a well-defined structure, that is, tasks which tend to be performed in similar ways every time, rather than those that have a very loose structure. HTA involves describing the task in terms of task subtasks, hierarchy, and a set of plans that define in what order subtasks may be performed, or under what circumstances particular subtasks are performed at all. Example: we will start with a simple example introduced earlier, writing a letter and preparing it for posting. Initially, we consider the description of Linda's activities. Linden's activity. Description of task. First, we observe Linden, who has no computer support, performing these tasks in her office. She finds a sheet of paper, a matching envelope, and a pen, and settles down at her desk to write. Second, she starts by putting her own address in the top right-hand corner, then picks up her address book and flicks to the page containing the addressist's address information. She copies the addressist's address to the paper, then writes today's date and start on the body of the text, Dear. When she has finished, she signs the letter. Third, then reaches for the envelope, writes the name on it, and copies the address from the address book onto the envelope. Last, fold the letter, puts it into the envelope, and seals the envelope. Task complete. One of the standard ways to presenting a HTA is as a tree structure. Write a letter and prepare for posting. First, you have to prepare for writing. Second, write the letter. Third, prepare envelope. Then last, put the letter in envelope. There may be some of notation you are familiar with where the order of appearance of boxes in the tree indicates ordering. The only thing that matters is the hierarchy. As well as presenting the hierarchy, it is necessary to describe plans that define the possible ordering of activities. In this case, a suitable plan would be Plan O, do 1, then 2, and 3 in either order, then 4. Although tree structures are visually appealing, well, more appealing than the alternatives anyway, they can be tedious to draw without a suitable tool. Therefore, an alternative text-based notation that relies on indentation is often used. We will use this textual notation to expand the task description of the letter writing task.
We need plans to describe how to perform each subtask. Plan 1. Do 1.1, 1.2, 1.3, and 1.4 in any order. Plan 2. Do 2.1, 2.2, 2.3, 2.4, then 2.5. Plan 3. Do 3.1, then 3.2. Plan 4. Do 4.1, 4.2, then 4.3. Task analysis involves generating as general as description as possible. So, for example, we might want to generalize task 2.1, 2.2, and 2.3 to a new task. Write head of letter. Similarly, we might notice that it is not necessary to have the envelope to hand until the time when it's to be prepared, or the paper to hand until the point where the user starts writing the letter. But we need the pen and address book for both, so we might break down task 1. If we do these things, we get a new structure. 0. Write letter and prepare for posting. 1. Get paper. 2. Get envelope. 3. Prepare for writing. 3.1. Get pen. 3.2. Get address book. 4. Write letter. 4.1. Write head of letter. We need plans to describe how to perform each subtask. Plan 0. Do 1, 2, 3, 4, and 5. Then 6.3 must be done before 4 and 5. 1 must be done before point 4. 2 must be done before 5. Plan 3. Do 3.1 and 3.2 in either order. Plan 4. do 4.1, then 4.2, then 4.3. Plan for Plan 4.1, do 4.1.1, then 4.1.2, then 4.1.3. Plan 5, do 5.1, then 5.2. Plan 6, do 6.1, then 6.2, then 6.3. We see that now different parts of the task analysis are presented at different levels of detail. This is often, though, thought of as a bad thing, but in this case, it allows us to describe the optionally and alternative orderings within the task more clearly. As with most aspects of design, there is no perfect solutions, just solutions that are better or worse for particular purposes.
Data collection. Collecting data about the task people perform may be more difficult than is apparent at first sight. We are dealing with human psychology and that itself is complex. This is perhaps another reason why some designers would really rather not involve themselves in user research. There are a lot of methods for data collection and your objectives and values, and ethical considerations will influence your choice of methods as well as practical consideration of what possible. Some method of data collection. Number 1. Observe the user working. Number 2. Talk to them informally in focus groups or interview. Number 3. Read available documentations or training materials. Number 4. Do the task yourself. Number 5. Familiarize yourself with existing system. Number 6. Analyze real tasks. Number 7. Develop abstractions of real tasks. Number 8. Conduct experiments. Number 9. Use ethnographic method, social proofs, conduct surveys, etc. Number 10. Contextual and queries. You can use more than one method so that your designs could be more flexible and sufficient. User-centered system design. We have known from the first chapter that user-centered system design is a system developed techniques that use natural competitions as a guiding principle. Just like any other system developed techniques, UCSD has its own process. Number 1. Task analysis. Number 2. Requirements gathering. Number 3. Design and storyboarding. Number 4. Prototype implementation. Number 5. Evaluations. And number 6. Installation. There are three key terms in UCSD that can be seen from the process it has. Number 1. Analyze users and their world. Number 2. Evaluate ideas. Number 3. Test to be sure the design works well.
Key activities of UCSD: task analysis inputs, problem statement, observation of existing system, analysis of user population output, hierarchical task analysis importance. It provides a clear understanding of what users want, and it is rare for an original design to be made. Usually something existing is redesigned or improved. Number 2. Requirements gathering inputs. Hierarchical task analysis, usability principles, uh, heuristics, relevant user models, other constraints, example external standards, hardware platform, output. Statement of requirements importance. It provides an explicit, testable description of what is wanted of the system. Number 3. Design and storyboarding inputs. Statement of requirements, stability principles, heuristics, other constraints outputs, a storyboard design, system justification, why the system is going to be the way it is. A first draft design of how the system works and looks like. A stakeholder needs analysis importance. It enables uh, it enables the designer to fully visualize their design and also for the client to have something to look at without studying the complexity of system design. Number 4, prototype implementation inputs, storyboard design, evaluations from previous iterations outputs, a working, testable prototype importance. It provides a relatively low-cost implementation that real users can usefully test. Different types of prototypes. Number 1, Wizard of Oz, controlled by the designer behind the scenes. Number 2, horizontal prototype, simulates the user interface only, no functionality. Number 3, vertical prototype, full functionality but with a little splice from the system. Number 4, for full prototype, complete functionality but low performance. 5, evaluation input, working prototype, statement of requirements outputs, transcripts of evaluations, what we said, what was said and done during evaluation. Evaluation report, are the requirements met? If not, why not? Importance. It provides tangible evidence of how system is actually used. Heuristic evaluation, common approach to usability evaluation, teams of 5 evaluators. Each of them inspects the system or prototype independently, noting any features that seem to be problematic. The team discusses its findings. User scenario are often used to assist the evaluators. Evaluators may also include reference to the usability principles and an estimation of errors severity. Number 6, installation inputs, a fully featured prototype outputs, an acceptable evaluation of the finished system. Task analysis is the process of analyzing the way people perform their job. Task decomposition breaks down tasks into subtasks. And also it can be the beginning of capturing requirements. There are different techniques for task decomposition including task hierarchy analysis, knowledge-based analysis, entity relationship analysis, and data source. Task hierarchy analysis means break down a major task and their subtasks in a way that declares the order and condition. The granularity of subtasks depends on the purpose of task analysis. Stopping rules are classified in 3 groups. 1. P. Probability. C. Cost. Threshold. 2. The point that the number of interaction points were increased to 3. The point that user have to make a decision. And knowledge-based analysis. At this method, a list of all object action that are related to the task prepared and then build taxonomies. The point at this method is people with different expertise and point of view do it differently. Additionally, group can be mixed, changed, and created. Entity relationship analysis tries to categorize objects and actions. but it also emphasizes on the relationship between them. Taxonomy has less priority. Relationship is defined between objects, system, actions, and events. Data source is focused on the source place that information about tasks can be found. Task observation is one of the solutions for doing this method. By passing observation, we can find where questions are being asked and seeing the actually task that is being done, but is very time consuming. Conclusion: hierarchy task analysis is best for decomposition simple tasks, and knowledge based analysis is better for complex tasks. That's all. Our presentation it's all about hierarchical task analysis or HTA. And I am a leader of this group. I am Joe Marieri, and my members are Armar, Grace, Kyle, Archie, and Regine. Thank you.